Hi anyone who is watching this video. This video is an introduction to our final project of EECS 475. This project consists of two parts, the data collection part and the winning rate prediction part. Let's start with the data collection part. There are three kinds of data that we will use to train our model: the pre-game data, the early game data, and the end-game data, aka the in-game data in the Python code. We choose Cassiopeia as our tool to get match data. Cassiopeia is a Python library which integrates the Rails APIs and make life much more easier. And then we clean up those data, pick only the fields that we think is useful. And this is the code. Maybe there is not so much things that we can see from it directly, but we can just run it. And you can see we start requesting the Rails APIs for the match data, and each match data may need 10 times of request. And this is the final data we got. This is the early game data, and the in-game data, and the pre-game data. This may look like a mess, but actually they formed in some kind of structures. Maybe you can figure it out in our Jupyter notebook. Till we make this video, we collect 1077 match data. It may sound not so much, because there are some limitations of Rails APIs, but we still got great results, and you will see it in the next part. So let's move on to the next part, the model training and winning rate prediction part.
We collect 1077 matches as data. Each match data contains pre-game data, including champions information and champions mastery information, which means how well the player plays when using this champion. When calculated accuracy, we pick 90% data as training set and 10% data as test set. First, we use naive Bayes classifier to make predict on pre-game data. We only use one information in this method, which is the 10 champions used in the game. And the naive Bayes method shows a prediction accuracy of 51.96%. If we randomly guess a result of this match, it will be 50-50. So we can see that which champion to pick can influence the match result, but only a little. Then we use champions mastery as features. It is basically calculated by the times the user using this champion. The value varies from several hundreds to more than 1 million. This feature is different, so we use three new methods. The KNN method shows a prediction accuracy of 55.23%, and the random forest shows a prediction accuracy of 56.10%, and the gradient boosting machine shows a prediction accuracy of 57.89%. In early game data, we have four different features: the features of gold earned, damage on champions, creep, and experience of two players from different teams in the same row. These features can represent most of the situation early of the match. The KNN method shows a prediction accuracy of 72.05%, and random forest shows a prediction accuracy of 71.27%, and the gradient boosting machine shows a prediction accuracy of 71.10%. The three methods shows nearly the same result. Each of the methods comes a result more than 17%. It means that if we have information of the first 10 minutes, we are more than 70% likely to successfully predict the outcome of the match, which on average lasts for 25 to 30 minutes. In-game data contains damage dealt, gold earned, kill-death ratio, first blood, first inhibitor, first tower, dragon killed, baron killed, total tower destroyed when the game ends. Like before, we calculate the difference of all the features between two teams. There are almost all the features we can get for a game. Using this information, we can almost predict the outcome of the match. The KNN method shows a prediction accuracy of 85.75%. Random forest shows a prediction accuracy of 95.60%, and the gradient boosting machine shows a prediction accuracy of 95.58%. For the random forest method and gradient boosting machine method, the results are all more than 95%. Because when the game comes to 40 or 50 minutes, the influence of these features will be less and less. All the player will have the best item around 45 minutes, even if he had disadvantages in line early in the game. So if any team wins a team fighting at that time, they will win the game. 95% is pretty reasonable result for in-game data. As for the KN method, the result is only 85% accuracy. I think the reason is KN method that have the weight for each feature and we didn't normalize the data. So the damage will take advantage in these features. But it is really not that important, so the result is not as good as it should be. For more details of the discussion and analysis, please see our Jupyter notebook. Thanks.